Alright, so let's go over a warm-up first, then we'll go over homework, then we'll have our quiz, and then, guys, we're learning trig, and I'm so excited for it. Okay, so hopefully some of you guys are able to acquire calculators between here and now. Raise your hand now if you still don't have the calculator to use. Guys, I think we're going to be okay. Okay, thank you for those of you that did acquire. Alright, so our warm-up here, just a refresher on our geometric mean. I still have it written up on the board over here. But just a reminder, our geometric mean. Geometric mean is when we have a right triangle with the altitude drawn in. We have our altitude, we have the pieces of our hypotenuse, and we have legs. Our two setups, our altitude breaks up the hypotenuse into the pieces. So my altitude is the geometric mean of those pieces. Hit one, hit two. Remember, geometric mean is always bottom of one, top of the other. Now our leg is the geometric mean, so it goes in the geometric mean location. My leg, and I'm going to talk about leg 1 here, is the geometric mean of the entire hypotenuse. Entire hip. And the piece closest, so the one that it's connected to. Same idea. If I were to use leg 2, then I would do the entire hypotenuse and the piece closest to that, which would be 2. Okay, so that's what we're doing for our setup here. So we don't have altitude, we have a leg though. So my leg is my geometric mean. And the entire hypotenuse, which is y, and the piece closest, which would be 20. Do we agree with this setup? Okay. So then I would probably go ahead and simplify first. Let's see, what does 24 over 20 reduce to? 6 over 5? Alright, I'm going to multiply. You can cross multiply. I'm just going to multiply by 24. Are we confused? Are we okay? Sorry?
For the for this, I use 20%.
You could have done that as well. Yeah, that's fine. And then you would have solved for your x that way, the fun one. Yeah, that's fine. Alright, so then let's go and multiply this. Let's see, 6 times 24. We can't reduce 5 and 24. Man, what a fraction. Alright, so 6 times 24. What's 6 times 20? 120. 6 times 4? Well, 120 and 24 gives us? What was that about? 144 over 5. So that would be my entire thing. And then I would need to subtract 20 to get my x. So we can go ahead and do that. Or you could have done what Tara said and set up your geometric mean, where instead of saying y, you could have said x plus 20 for the whole thing, and then cross multiply. Let's go ahead and just remind you how to do fractions. I'm going to go ahead and subtract by 20. And I want to multiply by 5 and 5. What's 20 times 5? Okay, good. So this is, I'm doing some bad math here. 100 over 5. So what's x going to be? 44 over 5. Alright, show me thumbs how we did with that one. We got some fractions for answers, so that always complicates things. I'm not seeing everyone's thumbs. Come on, I want to see everyone's thumbs. Yay, meh, nay. Alright, those of us that are here. Do we have questions now that we've seen how to go about it? Alright. For number 2, we have a leg and an altitude. If I have my setup for my altitude, I have y as my geometric mean. So my altitude is my geometric mean. So y is my geometric mean of the pieces of my hypotenuse. Well, I know that this piece is 9. What is this piece going to be?
9 minus 1. Or x minus 1.
Good. The whole thing's x. This would be x minus 1. Now the problem here is that I have both y and x. Not enough information to solve for both of them. So let's go ahead and look at our leg instead. So my leg is the geometric mean. My leg is the geometric mean of the entire hypotenuse, which they gave us the entire hypotenuse was x, not x plus 9, x. And then the piece closest would be, ooh, I like where this is going, x minus 9. Questions on our setup?
Isn't that the one piece you're oh, wait. I'm doing it. Who are the altitude?
Okay. So when I cross multiply, do we end up having to factor? X squared minus 9x equals 36. So x squared minus 9x minus 36 equals 0. What does this factor into? Good. X minus 12x plus 3. So I get x equals 12, x equals negative 3. X is a link though, so I can't take the negative. So I do get x is 12. And so now I can use that to find my little piece here. What's this little piece? The whole thing's 12, and we know that's 9 what's left of 3. So now I can finish this guy out. Oh, this one's not too bad. Y squared equals 27. Square root, break up your square root. 9, 3. So y equals plus or minus, but again, we can only take the positive. So I have 3, 3. Questions with that one? Once you find that this is 12 and this piece is 3, you could have also done Pythagorean theorem. Then 3 squared plus y squared equals 6 squared. That would have gotten you the same result. Actually, with thumbs, how we did on the set. Second was a little better on second. Any questions for those of us that were mediocre? All right, let's go ahead and take a look at our homework. Okay, computer's back online. Alright guys, so today, like I talked about before, is one of the most important things that you'll learn in geometry. All of it's important, but this is super, super important. This is built upon heavily in pre-calculus in 2 years, so you cannot forget this information. Okay? So not only will I visit you at your 90th birthday party to make sure you haven't forgotten this, but I'll also visit you in 2 years to make sure you haven't forgotten this. Do you need one more? Okay. Alright, so what we have today are called trigonometric functions.
Do you have another one?
No, you cannot use it.
I did not.
No, you're fine. Would you be using my phone for a calculator? Does anyone have a calculator now? So you don't need the calculator right now, so put down the calculator, stop typing hello on it, and let's take a look at what we have for today. Alright, so trig ratios is just simply comparing two particular sides of a right triangle. So our trig ratios can only be used with right triangles. And in our right triangles, obviously we have a right angle. And everyone knows where their hypotenuse is. It's across from our right angle. Now, we have two other sides. We have our two legs. Depending upon which angle we're going to be taking the ratio of, that will determine which side is our opposite, which sides are adjacent. So for this particular picture, we're looking at our angle x here. So this particular angle. The side opposite would be the side across from it. The adjacent side would be the side that's connected to it. Okay? Now, obviously, if I were to take a look at my other angle, let's call this y, the side opposite would now be here. The side adjacent would be this. So your opposite and your adjacent side depends upon which angle you're doing the ratios of. All right. So trig is just simply comparing two particular sides of our triangle. Now we have three trig ratios. The first one is sine, and we abbreviate it in math SIN. The second one is cosine, abbreviated COS, and the last one is tangent. So this is sine, cosine, and tangent. Now sine always compares your opposite side and your hypotenuse. So sine of an angle, meaning we're taking this particular ratio with this as our angle. Cosine of this angle is always adjacent over hypotenuse, So again, we're doing cosine of an angle, and depending upon our angle, that will determine what's our adjacent, what's our hypotenuse. And then tangent is always comparing your opposite and adjacent. You do need to commit this to memory that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Because it's such an important thing, many years ago, some genius decided to come up with the little acronyms here. So, ka, toa. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, ka, toa. So when I think of this, I think back to Finding Nemo. You guys were around for Finding Nemo, right? This was after you were born. And you know how there's the Mount Wanahakalu, they're like, wah, ooh, ah, ee, ah. So now you should think of so-ka-toa, 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 so-ka-toa. And then you get really excited about it. So that's what we have, so-ka-toa. So again, this is just a comparison of two particular sides. The sides that we're looking at depends upon which trig ratio we're doing. All right? So sine, cosine, and tangent are operations, all right? Just like adding, subtracting, multiplying, dividing, square rooting, squaring, those are operations. Sine, cosine, and tangent are operations. It just tells us which sides are we comparing. So we're going to first start by setting up our ratios here. And again, they have to tell you which angle to deal with. For this one, we're just going to be looking at angle x. We don't know what the angle measure is, but we do have our sides for a triangle. And so we're going to go ahead and find our ratios. So I want to find sine of x. It's just simply saying, what is the ratio of your opposite and hypotenuse sides? So looking at x, what is my opposite side? 2. What is my hypotenuse? Square root of 5. So sine of x is equal to 2 over root 5. In other words, the opposite over hypotenuse sides of my particular angle here is 2 over root 5. But again, in math, we cannot leave it as a root 5. Just like in English, we have particular formatting rules. In math, one of our formatting rules is no radical in the denominator. So impress your parents and everyone around you. Rationalize that denominator. And we get 2 root 5 over 5. All right, so let's go ahead and do our ratios for cosine and tangent. So our ratios for cosine of x. Again, this just simply means that I'm comparing adjacent over hypotenuse for the angle x. All right, what's my adjacent? 1. And my hypotenuse? 5. And again, we must rationalize. So I get root 5 over 5. So cosine of x is root 5. Questions so far? And we'll continue with tangent. So tangent of x is just simply saying we are comparing the opposite over adjacent sides for angle x. What's my opposite? 2. And my adjacent? 1. 2 over 1 is just 2. So for this particular angle, comparing our side, this particular angle in this triangle, comparing our sides, our opposite over hypotenuse is root 5 over 5. Our adjacent over hypotenuse is root 5 over 5. And our opposite over adjacent is 2. Okay. So I want you to, let's take a look at this guy here. So it says find sine, cosine, and tangent of angle A for each triangle. So I want you to just go ahead for this one here. Again, you're going to do this for angle A. So we're looking at this angle here. I want you to go ahead and find your ratios. What is sine of A, cosine of A, and tangent of A? And you need to write that out. Sine of A equals, if you just write 3 fractions, I don't know which one is which. So go ahead and figure out your ratios, sine, cosine, tangent, and simplify. Always, always, always simplify. Once you get your answers, go ahead and compare with your shoulder partner. So guys, make sure you have a sine of A equals. Sine of A equals a ratio. So we should have a ratio.
What if you bring it to 1? What if it's just a 1?
Alright, I'm going to go and throw up my answers. Oh, these ones didn't even simplify, did they? Oh, well.
No, like the same times 1. Instead of like.
Alright, so sine of A, we should have gotten 5 over 13. Cosine of A, 12 over 13. And tangent of A, 5 over 12. Do we agree? Okay. Now, I want to take a look at something else with this. What if, actually, let's put this one down here. This one here. So I'm going to slightly change the directions here. It says find sine, cosine, tangent of our angles A, B, Y, and S. Let's just stick with this one. And let's together go ahead and find sine of angle A, cosine of angle A, and tangent of angle A. And then we're going to compare that to what we get for sine of angle B, cosine of angle B, and tangent of angle B. Okay, so again, sine, cosine, and tangent, we are only using on our right triangles. And our other triangles, we don't even have a hypotenuse. Aiden, put it away. We don't even have a hypotenuse in other triangles. We have to have hypotenuse, gotta have a right triangle. Alright, what is sine of A going to be? Here's my angle A. Remember, we have SOHCAHTOA. So sine is opposite over hypotenuse. What's our opposite? 18. Our hypotenuse? 30. And what can we simplify this down to? 9 over 15. Oh, we can go even further. Sweet. Alright, cosine of A, what do we get? Unsimplified, what's our answer? 24 over 30, yeah. Adjacent over hypotenuse. Alright, let me write adjacent over hypotenuse here. Go ahead and simplify that. What do we get? 12 over 15? Do we agree? 4 over 5. Awesome. Okay, tangent of A. Tangent is opposite over adjacent. 18 over 24. And opposite over adjacent. And what is 18 over 24 reduced down to?
3/4.
3/4. Thank you for knocking that out in one step because I didn't have much more. Okay, so sine of A is 3/5. Cosine of A is 4/5. Tangent of A is 3/4. Okay, so I want to compare how that is with sine of B. So now we're going to look at angle B. Notice now my opposite and my adjacent have changed. So sine is opposite over hypotenuse. So opposite over hypotenuse. What's my opposite now? 24. Hypotenuse is still 30. What does that reduce down to?
4/5.
All the way down?
4/5.
4 over 5. Okay. Cosine. So cosine is again, so ca, adjacent over hypotenuse. So here's angle B. What's my adjacent? 18. Hypotenuse is 30. What does that simplify all the way down to?
3/5.
3/5. Alright, do we agree with 4/5 and 3/5? Okay. Now tangent of B, again, TOA, opposite over adjacent. My opposite is now 24. My adjacent is 18. What does that simplify all the way down to? 4/3. Okay, take a look at this. Sine of A was 3/5. What's cosine of B? Ah, that's interesting. Cosine of A was 4/5. What's sine of B? 4/5. Tangent of A was 3/4. So what was tangent of B? 4/3. So that's an interesting thing to note there. A and B are complementary angles, right? So in a way, they kind of go hand in hand. They have to add up to be 90. So we find that interesting link as well. Sine of one and sine of the other, or sorry, I should say sine of one and cosine of the other end up being the same value there. Cosine of one and sine of the other end up being the same value. Now, it's not often I'm going to be making you find the 3 set of ratios for both angles. It's not often going to make you do all 6 here. But it's just something interesting to note. You'll notice something with that in our chart too. Okay, and then also notice what happened with our tangent of A value compared to our tangent of B value. It was reciprocal. Why do you guys think that flipped? Take a look at your triangle and our sides there. What sides do we compare? Why do you think our tangent of A ratio flipped to be our tangent of B ratio? What did you say, John? They're utilizing the same sides, but in a different order, right? When we changed angles, it changed which was our opposite adjacent. All right. So this is just simply setting up our tree. We don't have to use any calculators yet. We don't have to use that chart there. This is just when we don't know our angles, but we do have our sides. We can set up the ratio of our sides. But now, let's take a look at when we do know our angle measures. So go ahead and flip this over. So now let's take a look at this. Here we don't have a triangle at all. I don't know the sides at all. But I can still find my ratio. What's interesting is that no matter what size of right triangle I have, no matter how large or small, if I have a right triangle with 48 degrees as one of my angles, what would my other angle be? 42, right? They have to add to be 90. So we know that the triangle would have to be at angle 48 and 42. But no matter how large or small, every time that I do my sine of 48 degrees, so using my angle 48 degrees, my sine, what does sine compare again?
Opposite.
Opposite over hypotenuse. Good. So sine of my angle is opposite over hypotenuse. Every time I compare my opposite side to my hypotenuse, it simplifies down to the same ratio every single time. So remember, we could have similar triangles where they have the same angles, but one's larger, one's smaller. It doesn't matter. Any triangle that is a right triangle with 48 and 42 degrees, when I compare those sides opposite over hypotenuse, it will simplify down to the same decimal every single time. Right? So now we're not going to use the calculator yet. Get out that little chart that you've got there, that little half sheet. Guys, I have gotten from the archives my high school geometry textbook. Look at this. This is the teacher edition. I have the real one that was mine at home. Mine and my husband's, I'm not sure. But this is my high school geometry textbook. And in here is this beautiful chart that I used back when I was your age, many moons ago, of our trig values. I have that for you in front of you. So let's take a look at that chart. It says sine of 48 degrees. We go to the chart. We go to our column of sine. We go down to our angle of 48 degrees. Oh, it's over here. We go to sine, 48 degrees. What is sine of 48 degrees? 0.7431. That's our answer. Sine of 48 degrees is 0.7, what was it? 4. Thank you. So no matter how large or small my right triangle is with a 48-degree angle, the comparison of our opposite to hypotenuse will simplify down to this every single time. All right, let's do cosine of 89 degrees. We go to 89 degrees. We go to cosine here. And what's our angle? What's our measure? Cosine, not 0.175. Good. 0.0175. What was it again? 0.0175. All right. And just for kicks and giggles, let's go to tangent of 57. You guys do that one. What's tangent of 57? 1.5399? 1.53. Yes.
I have to get it.
Oh. Here's your homework. Remember, homework is worksheet 3 and the rest of it is okay. And then that's your homework. Okay, so every single time that I do cosine of 89 degrees, no matter how large or small my triangle is, a right triangle with an 89-degree angle, cosine is adjacent over hypotenuse, compares down to 0.0175. Okay, So now let's take a look. So this is what we had to use back before calculators were a thing, right? This table, someone worked really hard to create this table for us. But now we're in the luxurious world of calculators. So go ahead and get out your calculator. And on your calculator, I want you to locate sine, cosine, and tangent. Now, in our world of geometry, our angles are measured in what? What's our unit for angles? Degrees. Angles can also be measured in radians. That's something you don't deal with until pre-calculus. So we are in the world of degrees. The first thing you must always do is make sure you're in degree mode. If you have a graphic calculator, you hit mode. By default, it will be on radians. We need to change it to degrees. So you just arrow down and go over and hit degree. If you have a scientific calculator, there should be a little marking on your screen that either says rad or deg. You want to make sure it says degree. There should be a key somewhere on your calculator that allows you to change that. Okay, is everyone in degree mode? So we hit mode, go down and change it to degree. Once you change it to degree, so you arrow down and then arrow to right, go ahead and hit second mode to quit back to your home screen. So we're now in degree mode. If you do radians, you're going to get the wrong answer every single time. Okay, so our first one that we did was it sine of 48. So we're just going to type into our calculator sine 48. Now that chart is the value rounded to 4 decimal places. It is an irrational number, so it is not a nice just 4-place decimal. So this is the full decimal. In here, we're going to go to 3 decimal places unless otherwise specified, okay? You can always go more. You're always welcome to go more, but we're going to go to 3 unless told otherwise. So 0.7431. Oh, looky there. That's what they did. Such hard work on that table for you. So now what you go and use your calculator, do cosine of 41 and tangent of 85. Yes. Okay, so now you're in degrees. So let's go to 3 for these ones. What do we get for cosine of 41? 0.7547. So I'm going to round and go to 3.755. Awesome. Raise your hand if you did not get 0.755. Everyone's in degrees then. Perfect. All right, what do we get for tangent of 85? What do we get?
She wants to start with
11.430. Are you alright?
Yeah, why are you only going to the third one?
Oh, I just said 2.
Oh, okay.
I just decided to change my mind halfway through. Okay, so we're going to use this when our values are not so nice. Now we'll learn, I don't know if we did today, maybe it's next class. Next class, maybe during Stinger. Here soon, you're going to learn that there are a few values that we can immediately know our answer to. But most of them are going to be decimals like this. Okay, so we're going to use this information to help us find missing sides. We have sine, cosine, and tangent create for us an equation. Sine of x equals the ratio of opposite of our hypotenuse. Cosine of x equals adjacent over hypotenuse, and tangent of x equals opposite over adjacent. This has created equations for us, so we can now use these to solve for unknown values. So, for example, with letter A here, I can't use Pythagorean theorem to find my other sides because I don't have enough information. I can't do a geometric mean. I don't have an altitude drawn in. So with this limited information before today, we didn't know how to find these values. But now after today, with our trig, we can go ahead and find our x and y values. So first of all, let's look at our angle. X in comparison to my angle, is this my opposite or my adjacent? Opposite. Which trig function uses opposite? Sine, good. So remember, so, not sin, sine, so, katoa. Alright, so sine of 36 degrees equals opposite, what's my opposite? X over hypotenuse. What's my hypotenuse?
152.
152. I'm going to move this down because I did not give myself enough room. Okay. So now we have an equation that allows us to solve for x. If I'm currently dividing by 152, how do I get rid of it? Multiply by 152. So I'm just going to simply multiply both sides by 152. Now, if we did not have our calculators or our table there, then we would have our answer as 152 sine of 36. But now that we do have our calculators, we do have our table, we're actually going to find that decimal value. You will finally be given decimal answers. So go ahead and you're literally going to type on your calculator 152 sine 36. So I'm going to type 152. You can write the multiplication, it's not necessary. Sine of 36. Did you guys get 89.343? Awesome. So I have then that x is approximately 89.343. It is proper to write the approximately because it's not exactly that since we rounded the decimal. I would highly recommend that you write the approximates. Okay. So how do you guys think I'll find y? What trig value should I use? Which trig function? Cosine. Why am I using cosine for y? It's our adjacent. So we don't know our adjacent, but we do know our hypotenuse. What connects the adjacent hypotenuse? Alright, so I'm going to do that. So cosine of 36, again, I'm still in reference to this angle here. Cosine of 36 equals my adjacent, y, over my hypotenuse, 152. Alright, and again, I'm going to multiply both sides by 152. So y equals 152 sine of 36. Got to punch that into your calculator. What do we get? Is it more or less than 200?
122.971.
And 122.971. We around it? You don't need to write this intermediate step here. If that's helpful for you, great. It's not necessary. Also, too, we technically could have used tangent since we now know x. But I don't recommend it because that would give me a rounded value. So whenever it's possible to use the given values, use the given values. If you are going to use a decimal that you found, do not use the rounded decimal. Use the entire full decimal that they give you. Okay, so my recommendation is don't use the decimal unless you have to. But if you have to use it, don't use the rounded, use the full thing. Because you don't want to round and then round and then round and then round. Your answer can get pretty far off. Okay, questions with this? Awesome. Okay, I want you guys to go ahead and do this one here. Wait, where did x go? X is supposed to be right here. Alright, solve for x. First, think which sides do I have and which ratio will I use? Once you get your answer, double check with your shoulder partner. See if you got the same thing. Alright, what did we get for our answer? First of all, which trig function did you guys use? Tangent. So tangent of 68 equals, what was my opposite? And my adjacent? X. I would cross multiply this, guys. We would have x times tangent of 68 equals 6. So what you're putting in your calculator is 6 over tangent of 68. You should have gotten 2.424. So make sure you're doing 6 divided by tan of 68. You're not doing tan of 68 divided by 6. We had a little bit of a difference out here. All right, your homework worksheet 3 and textbook. If you borrow my calculator, please return it and erase your name.
Maya Franco, please come to the main office. Maya Franco, please come to the main office.
That was close.
Thank you.
Good question. I think those first 2 questions are either 2 or 3. Just good. Have a good day. I usually get to start around. Remember we do later on after this one, we'll have a course that goes by. So I got it. One was up here. So that's what we did.
I don't even know how to do that. I stuff, but I didn't know that. Perhaps. When I didn't know how to like didn't make any sense.
Let's hope that you got part of it right.
Maybe.
Yes. Thank you. Thank you. Yeah. Say again. 3, 4, 1, 3. I don't think this one rounded. Yes. Thank you. So, in here we're going to do 3 digits unless I tell you otherwise. So, if the 3 does not round up, number 5 rounds. Oh, I see what you're saying. You can always go more. You can always go more. So you could say, like 3, 4, 3, 4, that's but if you want to, you can always go more. But I would look for 3 or 0.343, and then you can do the all. Okay? And the directions will tell you if it wants just text or something.
You're brilliant, Ms. Martha. I found the sent email, the spreadsheet.
You know.
To do with my